Hello everybody. So here another video from the numeric blueprint. Today we're going to be spending some time to talk about linear regression lines, and we're going to be looking more specifically the regression line of y on x and x on y. Now this is one of the content that is done in both the AA and the AI course. So before we actually get going, here's a quick starter question for you, just a little warm-up, just to kind of revisit the PMCC and how we find the equation of the regression line. And of course we can use the GDC to be able to solve this question. So I'm going to get you to pause the video now, have a go at the question, and I'll discuss the answers shortly. So please do pause the video. Now hopefully you're able to solve this question, and hopefully we're going to check the answers, and hopefully we're going to see if you are able to do this with the GDC as well. So what I'm going to do is I'm going to put all the data, which is the waist circumference and the length, onto the GDC. Now just for this demonstration, we're going to be using only the TI-84. If you need me to show it with the other calculators, I'll be happy to do it as well. So let's get going with the TI-84. So I got this little app on my iPad, which kind of resembles the TI-84. But I'm just going to show you how this works, okay? So we're going to put in all the data into the calculator. So under L1, we're going to have 80, we're going to have 82, we're going to have 79, we're going to have 60, 65, 92, 90, and of course 81. Then we're going to go to L2. That's going to be 110. That's going to be 111. 102. Next one is 87. The next one is 92. 112. 110. And of course 100. Then we're going to go back to stat. We're going to go to count. I'm going to choose option 4. X list to be L1, L2. Press enter all the way. So you should be able to get the R value on the right, which is 0.9198. I'm going to round this answer to 3 significant figures, okay? Which is always by default what the IB is always looking when it comes to the rounding. So it's going to be 0.920 by using the GDC. Okay, so let's get back to this. So we do know that this is going to be 0.920. So the next question is comment on the result found in R. Now this value is really close to 1. 1 is basically the highest correlation coefficient that you could get, which means that there will be a relationship between the waist circumference and the length of the pants. If we have 1, which means it's a perfect correlation. So 0.92 is really close to 1. So this has to be a very strong correlation. And since this R value is a positive number, so we could easily comment on the result by saying that this is actually a positive, strong correlation between the waist circumference and the length of the pants. Okay, and think about this is like easy 3 marks in the back, length of the pants. Okay, so we got this 3 marks in the back. Now we're going to move on to the next bit. It says find the equation of the regression line, which is in the form of y equal to mx plus c. We do know that this is the general equation of a line, or what we call the gradient intercept form. And what we're going to do is we're going to put all this again onto the calculator. And in fact, we have already put in the data into the GDC. So we're just going to find out what is the gradient, which is m. And we're going to find out what that value is. And we're going to try to do some interpretation of this number in this given context as well. Okay, let's go back to the calculator. Now, back to this. So we do found out, now remember when we do the linear regression, which is ax plus b, a is the gradient, while the question says that m is the gradient. Okay, they're just variables, all right? It could be. So I know some students would have said that why does it not look like m? It's just the way the calculator is being designed. But a generally is the gradient that is shown on the calculator. It is the same thing as the m that is required in the question. Okay, so if you look at what a is, which is 0.787, again we're going to round this to 3SF, and we have b, which is basically essentially the value of c, which is 41.1, okay, which is 3SF again. So what we're going to do is we're going to go back to this, and we have m to be 0.8787. Again, I'm going to round this to 3SF. I'm just going to do part 2 at the same time, okay? So we know that c would just be 41.1. Again, to 3SF. Now what we're going to do is let's do some interpretations of what m is and what c is. Now, if we look at what m is, now let's go back to some the theory of gradient, the understanding of gradient. Now we do know that gradient is the same thing as rise over run, which is like the change in y divided by the change in x. Now theoretically speaking, if we have 0.787, we could have written this as 0.787 divided by 1. Now we do know that the x variable is the waist circumference, so I will just put the run, which is the change in x, and the rise, which is the change in the value of y. So if you look at the numbers that we put in, we have 0.787 and 1. So what does this actually imply? It just implies that every 1 centimeter change in the length is going to have a change in the waist circumference of 0.787 centimeters. Alright, let's just put that all in words. So C part 1, I'm just going to write it here because I'm running out of space. So the length of the pins will increase by 0.787 centimeters for every 1 centimeter increase in the waist circumference. Okay, so this is literally like your rise, and this is literally like your run. Does that kind of make sense? So that's how we do, that's how we interpret the gradient in this given context, in this case. Now let's look at C part 2. Now let's look at what 41.1 actually stand for. Now we do know that this is the y-intercept, okay? But we do know that to find the y-intercept, the y-intercept basically implies that the x has to be 0. That works for all straight line graphs. So when x is 0, and if we look at the context here, which is the waist circumference, is it possible to have the waist circumference to be 0 centimeters? I don't think so. It makes no sense. You can't have a waist circumference that's 0, which means that you are having someone who is shapeless, formless. So that obviously makes no sense. So in this case, it's obviously going to be inappropriate to use the value of 41.1. So all you need to say is that because it asks for explain why. So because the waist circumference cannot be 0. Okay. And there we go. 4 marks in the back. Alright, so hopefully this gives you a nice little recap of the Pearson Product Moment Correlation Coefficient, which is the PMCC, and knowing how to find the equation of the regression line as well. So what we're going to do today is we're going to spend a bit of time to talk about the regression line x on y. But before we do that, I do want to spend a bit of time to talk about what does it mean by having a regression line of y on x. Now, in the previous example, when we did the question on the waist circumference and the length of the pants, what we usually do is we always have graphs when the dependent variable is always going to be the y variable, and we have the independent variable to be on as the x variable. Now, this is actually what we call the y on x line, which is also basically the same thing as the line on best fit and the regression line. So what we have always been doing is having the independent variable to be on the x-axis and the dependent variable to be on the y-axis. Now, so today we're going to spend some time to talk about what if we swap the variables. What if we do something like that? What if we have this variable to be x and to have the independent variable to be y? Is it possible to do that? Now we're going to come down to the bottom of this. Now, so I'm just going to show you one example. This is obviously taken from the Hayes textbook, but I just felt like this is a great example to showcase why we could also use the regression line x on y, and it really comes down to the context of the question. I'm not saying that it could be applied all the time, but it really depends on the nature of the question as well. Now, so let's look at this and let's just really get down to the bottom of this. Now, we do have two sets of data, which is the feed eaten by 12 chickens and the number of eggs that's laid by the chickens. Now, if you think about this logically, I have a bunch of data saying that if the chicken eat 0.57 kilograms of food, it's going to lay 4 eggs. If it's going to eat 0.86 kilograms, it's going to lay more eggs. And again, if you eat lesser, which is 0.49, it's going to lay like 3 eggs, which kind of makes logical sense, because if you think about chickens, if they're going to eat more, I think the causal relationship would be, you probably be thinking that, yeah, if I eat more, the chickens eat more, they should be laying more eggs. So technically speaking, this is what you probably would think. That this should be the feed, and this should be the number of eggs, which is going to be the dependent variable, which makes sense. It just sounds logical to me. But what we really want to do is to find that relationship if we swap the variables. What if we have the number of eggs to be the independent variable? And what if we have the feed to be the dependent variable? So now the question would be, what is the relationship between these two variables when we swap the independent and the dependent variable? Is it possible to think about if the chickens eat more eggs, is it possible for them, no sorry, if the chickens lay more eggs, is it possible for them to eat more instead? Is there a relationship to that? Now, on the first thought, it might sound strange, but you can't really rule out that possibility, isn't it? Because if they actually lay more eggs, maybe they just get to eat more. You know what I mean? Just to see that relationship, trying to find out that relationship between that two variables in the way. It doesn't sound very natural, but then again, it could be possible if we go into more in-depth analysis of these two variables. So that's what it really means. But there is another catch to this as well. If you look at the data that's given to us on the number of eggs. Now, we do know that the number of eggs is a countable, is a discrete variable, and usually it will be easier to quantify an independent variable to be something that could be countable, because it's just natural, right? If you think about this, if you have an x value where which is a whole number, or like a discrete number in this case, then it's probably going to be much easier for us to quantify the amount of feed as well. And I think one of the giveaway when it comes to deciding or determining whether that whether an independent variable could be the variable given in the context is to look at whether the data is actually a discrete numerical variable, whether it's easily countable, and if it is, it really puts in a very good shout into whether a very good choice for an independent variable as well, because technically speaking, like we just said, whether the number of eggs that's laid by the chickens could have an impact on how much food they eat. It's not something that's very clear cut, but it is possible, but something that we can't rule out at the same time as well. But another catch, like I just said again, is that because of the fact that the number of chickens eggs that's laid by the chickens is a discrete numerical variable, so that puts in it gives it should I say a good possibility that it could be considered or regarded as a independent variable as well. So if you look at the first question, it says explain why it would be appropriate to use the regression of x against y. This really comes down, I would say, to the context of the question. Okay, like I say, we could have used logical sense or things that we are familiarized with to identify whether these two variables are connected or not. But in this particular case, it's not very clear cut. But I do think that at the same time, you need to be looking at whether the independent variable is discrete variable. Okay, something that's something that you could count. Is it countable in this case? And in this case, the number of eggs obviously is countable. So that really puts in a really good shout as a good choice for an independent variable for this case. All right. So so this is how we do determine how we could use the regression line of x against y when we do a little switch of the variables. It is very interesting, but one little tip from me would be, please do ensure that you look at the variables that's being given to you in the question. And I think that will give you a little insight into whether x and y if it's actually a possibility in the question as well. Okay. All right. So the next thing I would like to show you is how we could actually find the regression line of x against y. Now, we have found, or we have done the regression line of y against x in the previous example. When we did the pants and the waist circumference. That was a typical y on x line. But if we want to do x on y line, now have a good think. If we swap the variables, now then we should need to do some modifications to our calculator work as well, isn't it? So what I'll do is I'll show you a quick little tip. Back to our calculator again. Let's go back to stat. We do have L1 and L2. Remember, this was done based on x and y earlier, isn't it? Now, but what I'm going to do now is perhaps let's clear the data. Let's put in the new data that we have from the previous example. So I'm just going to show you very quickly on how we do this. Okay, so I'm going to clear my calculator first. So second mem, I'm going to reset this. Okay, and that just clears my calculator at the same time. Now, so let me show you how we could do this. Okay, so what we're going to do is, now originally this was considered as L1, this was considered as L2 because this was x and this was y. Okay, this is just simply an extended table from the previous one. Now what we're going to do is, because this is L1, this is L2, and this is based on the fact that this was the dependent variable, the independent variable, and this was the dependent variable. But now we're going to swap this. Okay, we will do a little swap. And so instead of putting the x to be under L1, we're going to do the y to be, we're going to have the x to be under L2, and we're going to have y to be under L1. Okay, so that means we're going to do a little swap here to have the values. So hopefully that's kind of makes some sense to you in the intention on how we could actually do this with the GDC as well. Okay, so without further ado, so what I'll do quickly now is to put these numbers onto the calculator. So I'll repeat what I just said again. This was initially L1, this was initially L2, but what I'm going to do now is I'm going to swap the values. This would now would be now to be L2, and this will become L1. Okay, so let's do a quick swap, and I'll put the number of x now onto L1. So let's go back to the calculator. So let's try this. Let's put 4, which is the number of x. This will be 6. This will be 3. This will be 9. This will be 6. This will be 3. Then this will be 6. This will be 7. 7. 4. 9. 6. And let's go up again. So let's put in the rest of the values as well, which is the feed. Okay, 0.57, 0.86, 0.49, 1.37, 0.91, 0.5, 0.97, then 1.06, the next one is 1, 0.68, 1.34, and 0.94. Okay, so basically we're done. Now, so just to go back to what we're supposed to do, we're supposed to find the regression line of x against y. Now, so we're going to find the equation by doing the exact same steps. We're going to go to stat, go to calc. We still choose option 4, nothing changes. It's still going to be L1 and L2. Now remember, the x list is now the number of eggs, and the y list is actually the feed. Okay, remember we swapped the variables, but when you put everything onto the GDC, nothing changes, because we have entered L1 to be the y variable, and we entered L2 to be the x variable. So there isn't anything that you need to change here, which is the L1 and L2. Okay, so what I'm going to do is I'm just going to press enter all the way, and you're going to get the A value and the B value. You're going to get 0.142, and you're going to get 0.0603. Again, we're going to round the answers to 3SF. Now, when it comes to writing the regression line of x against y, what you would do is, instead of doing y equal to mx plus c, you're going to actually be doing this, which is actually x equal to my plus c. Again, because since there is a swap in the variables, it's the same thing when it comes to the regression line of x against y. You need to swap the original y and the x as well. So the equation is going to look like x equal to my plus c. So again, we know what the gradient is earlier, which was it was 0.142, isn't it? And 0.0603 for the A and B. So we're going to write this down, 0.40. Wait a minute, my memory is failing me. 0.142 and 0. Okay. Alright, 0.142. Let's erase this one. Okay, so this should be written as, I'm going to use a different color, 0.142y plus 0.0603. There we go. So this is what we call the regression line of x against y. Okay, so I'm going to summarize a quick summary on what I just said earlier. When we do a regression line of x against y, what we are doing is basically swapping the variables, which is swapping the independent and the dependent variable. And before we apply the use of the regression line of x against y, or whether it's appropriate to use, it really comes down to the context of the question. Okay, these two variables in terms of the relationship, it's not exactly very clear cut whether the amount of feed that the chicken eat is actually dependent on the number of eggs they laid. So this is actually essentially what we're doing, and not forgetting the dependent variable, all right, which obviously was the feed, and the independent variable, which is the number of eggs. The number of eggs, which is the independent variable, it's a discrete variable which is countable, all right, which makes it a good choice as an independent variable as well. So that's what we have been doing on the regression line of x on y. Okay, so hopefully this kind of summarizes what we have done so far. Now, if we look at part 1, it says that we need to start to make some predictions. It says that, could you find me the quantity of feed required for the chicken to lay a dozen eggs? Okay, so let's say if we have like a bunch of points here, and I have the line of best fit that looks something like that, or the regression line. What it's saying that is that if you have 12 eggs here, could you find me what is the feed? And we could use the equation. We just got the regression line equation. We could easily do that because we know that a dozen eggs, that's the y value. So what I'll do is I'll find y to be 12, which is 0.142, and I'm going to multiply this by 12, and I'm going to add 0.0603. Okay, and all we need to do is to put this onto the calculator, which is 0.142 multiplied by 12, and we're going to add this to 0.0603. Okay, and that's going to give me the number of eggs for this one. So again, remember, you could obviously just use the calculator and just work out the answers for that, and that should really kind of give you the answer for the first question. Okay, and that also brings me to part 2. All right, to find the number of eggs that's laid by the hen, which is 1.2. So what essentially we're doing is putting 1.2 into x, which is 1.2 equal to 0.142y plus 0.0603 for this. Okay, so I'm going to leave to you to solve these two questions on your own, but hopefully this gives you a quick summary of what the regression line of x and y actually does. It is quite an interesting concept, which is basically the swap of the variables, but I just felt like this needs to be discussed more thoroughly. Again, it really depends on what context is given to you, what variables are given to you, and I think it's really helpful in terms of how we analyze using statistics, and how regression line can also be used in different scenarios. And hopefully this gives you a little insight into how the regression line of x and y works. Okay, so hopefully this video helps. I hope I have provided you with sufficient details. Of course, if there's any confusion, feel free to drop me a comment, and if you like this video, hit the like button. All right, and subscribe to my channel. All right, I'll see you again. Take care.